Ladies and gentlemen, dear colleagues, it's a pleasure for me to give the start to this parallel theme C Research Infrastructure and Sharing Scientific Data Globally session on data sharing regional initiatives. It's really an honor to moderate this session with a number of distinguished speakers. This session will present, covering important world regions, various infrastructure initiatives that either support implementing the open science principles or they rely on these principles to support excellent science. These initiatives share a common interest in technological support and promoting data sharing. The aim is to relate a different approach to each other, to identify commonalities and differences, and to show the impact on the adoption of open science by scientific communities. And after this preamble, without any delay, I want to invite to the podium Rosie HICKS. She is the Chief Executive Officer of the Australian Research Data Commons, and she will talk about development of the Australian Research Data Commons. Rosie, please.
Good afternoon. How's that for the volume? Think that's okay? Good, lovely, thank you. Well, I'd like to start by thanking you for having me here and by congratulating the organisers of ICRI 2022. Perhaps you're just beginning to relax a little bit now as we move through the day. But thanks for having me here. So we're looking at collaboration and challenges in this afternoon session. And we all come here intent on collaborating, but it's really, really difficult for us to read each other's minds. So what I'm going to do very quickly in the next 10 minutes or so is tell you a little bit about what we're doing in Australia at a high level. We're obviously necessitated by time. At a high level, happy to go into further conversations subsequently, but it will open the door to those conversations around collaboration. There we go. So in this morning's session, Karen shared with us the definition of a research data commons, and we had the global trusted ecosystem that provides seamless access to high-quality, interoperable research outputs and services. And I add to that here the definition of a research data commons. At the ARDC, we're bringing together people, skills, data, related infrastructure for storage, compute, and models. We talk about our purpose, and I say very, very simply, it's to provide Australian researchers with competitive advantage through data, and whatever that entails. But what I'll really draw your attention to is our mission. So accelerating research and innovation by driving excellence in the creation, analysis, and retention of high-quality data assets. So keep that in mind. The ARDC is one of Australia's 20-odd national research infrastructures that are funded through NCRIS. We are a non-profit company, limited by guarantee, and we have members across the country, largely Australian universities, and that list is growing, so I've got a couple more to add to the slide, but also we're now expanding to medical research institutes. To put this in perspective, we're at about 22 universities. Australia only has 38, so it's a very significant fraction. When I joined the ARDC, when it was incorporated about 3 years ago, we had a number of portfolios. You can see the 4 portfolios here on the screen. If we look at data and services, they include PIDs, that's a shout out to this morning's conversation, used for the creation of data assets. The analysis environment composes both the platforms, the software, the tools, and the compute. And then we look at data retention as well. And of course, to make all of this work, we've got to have appropriate people, skills, we've got to work with policymakers as well. That was the strategy on a page. What I want in the next couple of slides is just to give you a feel of the scale. So we have 122 co-investment projects in flight at the moment, which is a bit ridiculous. We work with a very large fraction of Australia's researchers. We've got 26 different projects underway at the moment to build national data assets. Some more here. Coincidentally, actually, we have 26 platforms being developed at the moment. We're working with 209 different groups to make those data assets, 1,300 collections of national significance in the data retention program. The scale is large. Drilling down on a couple of the activities here. The Hasanda program. That's creating a national health studies data asset, the translational research data challenges, and the humanities, arts and social sciences RDC, research data commons. The reason I've chosen these three is because of their contrasting delivery. In the Hasanda program, we're focused on making the results of medical research available, starting with clinical trials funded by the National Medical, NH&MRC, I'm trying not to use acronyms, National Health and Medical Research Council there. We have a very clearly defined data challenge that we're seeking to address with that program. So finding and accessing the results of clinical trials. We'll then move on to cohort studies, then we'll move on to medical registries. But it's a well-defined data challenge. The next step, the translational research data challenges, we're bringing together the pipeline of actors to allow us to connect research to impact. Our first translational research data challenge area was in bushfires. We're now moving into food security. So it's mission-driven, a very clearly defined endpoint. And then the third example I have here, for the humanities, arts and social sciences research data commons, we also have an indigenous research capability built in there as well. It's about building capability for a research problem that we don't yet know. Now, I'm hoping that I'll be able to share this pack through the organisers of ICRI, so the next couple of slides I won't dwell on. But there's something on the Hasanda, looking at the different components of that, the data services, federation, and coherent data practices. I would say it involves 72 different organisations across Australia. The translational research data challenges, creating that pathway to impact, you can see the actors there. And then the humanities, arts, and social sciences, that has started with 4 projects. One of the ones that I will highlight is the Linguistics Data Commons of Australia. And I think we heard in yesterday's opening sessions of the impact of bringing that social sciences data into our response for COVID. Okay, so we've got all of this in flight, and we've created those projects through a series of open calls. And that's fabulous. We're building some really great infrastructure. But then what? At the end of the project, what happens to that research infrastructure? How are we addressing resilience? How are we addressing sustainability? Well, you know what? We don't. And when I came into the Australian Research Data Commons, I was so careful. I'd spent 12 years running our national fabrication facility. I said, I'm not going to bring any baggage. This is a fresh start. I'm going over to the dark side. And then I arrived and I looked at how we were working and I thought, you wouldn't do that to a microscope. You don't build a microscope and expect it to maintain itself. What are we going to do for digital research infrastructure? And so we moved towards the concept of a thematic research data commons. We still have the same core competencies, creation, analysis, and retention of data assets, but we're going instead to put them to use in a very different way in a small number of strategic themes. Now, I've already shared the HAS and Indigenous capability with you. That's underway. We had to spend a lot of time thinking about where we focus first. We looked at where the research was concentrated in academia, in industry. We looked at government priorities. We looked at our own footprint of activities. And our first two areas are people, looking at health and medical research, and planet, looking at environmental, earth, geoscience, that's the one I'm forgetting, climate science, and you'll understand why I'm forgetting in just a moment when I explain a little bit more. So the delivery model of a thematic RDC, we all know that governance is absolutely critical in this space. We have expertise as the other part of the sandwich here. Without the skills, without the people, we're lost. What we'll be doing, though, is we will be moving more of our projects, the development of platforms, data assets, practices and standards, from projects to ongoing national services. So within a thematic research data commons, we will work with the community to design the content, to build that content, and continue to run it, to operate it, and maintain it as long as the demands are there. I am going at a rate of knots through things that have taken a lot of deep thinking, so, happy to discuss afterwards. Essential attributes for the Research Data Commons. FAIR principles we're all across. I'm not sure if you're all familiar with CARE, collective benefit, authority to control. I'm getting some nods here, thank you. Responsibility and ethics. The continuity for these activities is critical. And in Australia, we must recognise that Indigenous knowledge and data are essential for us to care for country. What we did is we set out through an extensive environmental scan and landscape analysis to identify the challenges for the health and medical research data, to test them with the community, and then modify them. And now we're up to that stage for people. Planet is not so far advanced, so we haven't tied the challenges down. So the people RDC Value Proposition, supporting health and biomedical researchers. The types of language I'm using here, the words, they're not going to surprise anyone in today's audience. Federated models that deliver interoperable compute, storage, infrastructure and services, analysis platforms and tools. What I would say to today's ICRI audience is that when I'm talking about interoperable, of course, it doesn't just mean in Australia. I'm talking about on the global stage, and that's an important part of today's conversation. The challenges that we tested with the community, have we got the right challenges? Have we missed anything? Are any of these fixed already? The feedback from the community was, no, they're the right challenges, and you're probably talking a 10-year plan. This is how we presented to the community. The really key point is how does an ARDC thematic research data commons fit with Australia's other research infrastructures? We're not seeking to replace them. We're seeking to create that seamless environment so that the omics data from Bioplatforms Australia can be linked with the National Imaging Facility and with microscopy analysis, for example. As a result of that testing, we have modified these challenges. So, for example, if I talk about data linkage for health data, we have a national backbone for linking health data. What we can't do on an ad hoc basis is link the results of a particular clinical trial into that national spine. That's an area that we have to look at. We're now at the stage for people that we have tested the challenges. We're bringing the community in that co-design process with us. We're at the stage of writing that first implementation plan. The process is being repeated by the team working on the Planet Research Data Commons. So we had the round tables just before I got on a plane to come over here. I've got the material in the pack, but I won't spend time on the slides. So again, a value proposition, very similar. Beautiful image of a Banksia serrata there for you, by the way, rather fond of them myself. we looked at the challenges in this space going through the research data lifecycle as you would use the data, and finally, the suggested data challenges that we have just tested with the community. So I don't have the results of that yet, the synthesis of the different roundtables, the prioritization of the data challenges that you see here. And with that, it's very much watch this space. The key themes are moving to a longer-term, more sustainable delivery of digital research infrastructure that's highly focused in a small number of strategic areas. And I'll conclude there.
Thank you very much, Rosie, for this interesting presentation of the development of the set of thematic research data commons in Australia, and also how you address the resilience, which is a very important issue. There is time for questions for Rosie from the audience. Yes? Suzanne?
Thank you. Thank you, Rosie. It was very, very inspiring. I would like to have a bit more detail on the care principles and how you manage them regarding the data, and how these are complementary to the FAIR principles.
Thank you. So the care principles are not as well advanced in Australia as the FAIR data principles, and so the key thing that I would point you to in response to that question is we worked with the Indigenous Data Network. So as part of the HAS RDC, we worked with the Indigenous Data Network to convene a very large group in June of this year to look at the implementation of those care principles and the governance framework for that data. So we're expecting the results of that in a publication to come out very soon. But what I would say is that throughout the conversation, so for example, in the conversations for the Planet RDC, the input from the Indigenous community goes right the way across all of the other discussions. And so it's moving to a point in our national discussion that it's very front of mind and it's not an afterthought. So I think we're on a journey, but I'm very positive about the progress.
Thank you. Thank you. There are no questions from people connected by remote, and therefore now I invite to the podium Eva DEELMAN. Eva is the research professor and research director, Information Science Institute, University of Southern California, USA. And she will talk about open data in the National Science Foundation major facilities from the point of view of the cyber infrastructure compass. So thank you, Eva, for being here with us.
Thank you very much, Marialuisa, and thank you very much to the organizer for inviting me to be here. As you mentioned, I'm going to be giving my talk from a point of view of CI Compass, which is an NSF-funded cyber infrastructure center of excellence that serves for major facilities in the US. So our role is to basically provide expertise and active support to the cyber infrastructure practitioners within the major facilities, and we focus particularly on the data lifecycle within the facilities, from the point of view of data capture at the instrument, at the sensors, to the initial processing of the data in situ close to these instruments, then the central processing in various data centers, to the storage, archiving, and curation, and then to the data dissemination, visualization, so that the public, the educators, and the scientists have access to the data. We also look at some cross-cutting issues such as data movement throughout these levels, fair data, and also identity management. And in that context, we help the major facilities evaluate their cyber infrastructure plans, perhaps architect new solutions, develop sometimes proofs of concepts, or look at new technologies and see how they could be applied within the major facility data lifecycle. So we have a number of activities within CI Campus. We organize community workshops, we have a student program, we have webinars, and we participate in meetings such as this one. We also have engagements with the major facilities one-on-one, or maybe with 2 facilities working on a particular problem that's specific to them. And we also organize topical working groups around issues that are in common to a number of major facilities. Currently, we have 2 working groups that are active, one looking at fair data and the other one on use of cloud technologies for major facilities. So one of the engagements that I wanted to point out in this talk was our engagement with NEON and NCAR, where the goal was to combine NEON ecosystem data with NCAR's atmospheric and land modeling capabilities. So the idea was to work with NEON to take the data that they make publicly available to the users, and then help them share that data with NEON's modeling capabilities and put the whole thing in a cloud environment so that it was broadly available to the user community. And as part of this, we also engage with ESIP, the Earth Science Information Partners, to make sure that the data standards that NEON and NCAR were using were also part of a broader community effort of developing standards for ecological data and other Earth science data. So these, in general, when we look at the US landscape, we saw a recent memorandum from the Office of Science and Technology Policy, which basically is directing the federal agencies to look at the open data procedures and develop new procedures that would make and recommendations that would make publications of the data publicly available without embargo. So the data should be available as soon as the publication is made. To develop transparent procedures so that the science that's being described in the publications is open and adheres to research integrity standards, and also provides equitable delivery. What's particularly interesting, I think, in that memorandum is that it's not only the data that's being published as part of the publications, but also there's a mandate to make the data that's collected by scientists, even if it's not attached to publications, open. And then the other part of it that's also important is now that the federal agency need to also provide guidance in terms of what repository scientists need to use to make the data available. So I think the discussions that we're having here at ICRI are very pertinent to this type of recommendations that the federal agencies need to make in the US. The other thing that really I think was interesting about this memorandum is that it says that in consultation with OMB, the agencies should allow researchers to put in their budgets funding explicitly for the data curation, for making the data available to the public and putting them into the repositories. And I think this is very important because normally we expect PIs to just make the data available without really looking at how much effort it takes. So we kind of say, oh, they should do it anyway. But here there's a recognition that it actually takes an effort and considerable time and resources to do that extra step in the work. So I'm glad to see that there's actually funding that's going to be put behind that. So when we talk about the NSF major facilities and the data that they collect, I think it's useful to think of what types of data they do collect and what type of major facilities we have. So from the work in CI Campus, we tried to look at 4 different categories of data that's being produced by the major facilities. You can call them collective data, community data, PI data, or kind of a hybrid of these. And so let me go quickly through some of these categories. So collective data, in this case, think of like high-energy physics, LIGO, CMS, IceCube, the neutrino detector in the South Pole. In these cases, these are large facilities where they collect the data, they calibrate it, and they analyze it as part of a collaboration. So the light gravitational wave scientists coming together, build an instrument, they collect the data, analyze it, they use it for their own research, and then disseminate it to the community. So the collaboration has actually all the details of the data collection. They can influence what data is collected. They build the instruments. And they also know how the data is analyzed, the developer analysis for that. And when the data is then first disseminated within the collaboration, then after an embargo period more broadly. So this is one type of data where you have basically a single steward of the data. Although the data is very complex, you have somebody that knows everything about it. And also the major facilities have all the tools to make that data available. Another type of facilities you can think of are those that generate community data. And here think of NEON, so ecological network, SAGE, which is a network of seismometers and other earthquake science instruments, and OI, which is an Ocean Observatory Initiative. So these major facilities, they collect the data, but the purpose of this data collection is to generate data for the community. So the major facilities do not directly conduct research on the data, they just make the data available. And the data then is used by the public without this embargo period. However, the public or the researchers don't have much influence besides community meeting as to how the data is collected, what type of analysis is made on the data. They do have access to other publicly available information on the data processing though. And however, the scientists take this data and generate derived data products, then they have this limitation of making these data products more broadly available to the community. And so here, although the data is complex, the major facility has all the information about the data, the metadata that goes along with it, and also the major facility has repositories that are built into the infrastructure. Now, there are other facilities that we can think of to generate PI data. So these are facilities such as shake tables, MagLab, which is a big magnet facilities in the US, CHESS, which is an X-ray source. And there the data is collected primarily by the PIs that come to that facility. They might also bring their own instruments as part of this data collection, which also complicates the data provenance. The scientists usually collect this data with a particular goal in mind that come from a particular domain. And so that also gives another layer of complexity. These major facilities serve multi-domain of scientists, so the data can be very varied. And the data products depend on various parts of a process. So the samples and how they were created, which may not have been generated by the PI or the experimenter that uses the facility. And then there's also data coming from the instrument itself and the experts that help at the facility that help tune the machine to give the data sets. So here I think this is a very challenging case because the data and metadata have different stewards, different people know different parts of a puzzle, and oftentimes the PIs maybe do not have enough expertise in the tooling or cyber infrastructure that they can use to annotate the data with appropriate metadata, what standards to use, and how to make the data available. So I think this is the type of challenges that I think are worth focusing on because I think they're representative of a number of research infrastructures and are quite complex. And then you have also the kind of hybrid data type of situation where, for example, think the research vessels that go out on cruises and they collect, the vessels themselves are instruments that collect information about the ocean over the bodies of water that they go on. And in addition to that, the scientists go on the cruises, they bring in their own instruments that are being put in the water on the air, and they collect additional data. So now you have kind of two data collections. You have a data that's collected by the vessels. You also may have data that's collected by the cables that are nearby in the ocean, and you have a PI instrumental data that's collected as well. And so again, you have now the problem that you have the data and metadata have these multiple stewards, so the knowledge is distributed. Putting that thing together takes time and expertise, and again, making dissemination of the data is complex in this case. There are some examples, though, and also that showcase how expensive it is to generate really high-quality data. So this is a mid-scale infrastructure in the US called the Research Data Ecosystem. They're building tools for PIs to access social and behavioral sciences data. This is built on 60 years of a collection that's been developed by the University of Michigan, where they have about 250,000 different files on these subjects. And they have 21 collections. And the effort it takes to really curate the data that's being uploaded to this repository takes 36 dedicated curators to really look at the data, make sure it's of high quality, that it's integrated with the rest of the collections. So I think we really cannot underestimate the human effort involved in making the data scientifically meaningful when it's being disseminated to the, to the community. So obviously, we need more community efforts, and so it's great to be in this forum and to hear about everything that's going on across the globe. Obviously, socializing the concept of open science and open data is very important, promoting the use of standards, but I see there are a lot of different standards and a lot of different communities. So I think if we think of a PI that comes in to our science ecosystem and how they think about where they go, where do they put the data, what tools are available to them. I think we need to think of these PIs and try to help them with appropriate cyber infrastructure tools, help them identify the repositories that they need to use. And I think more importantly, we need to provide more training so that people feel comfortable and can easily integrate into our open data and open science ecosystem. So thank you very much.
Thank you very much, Eva. We cannot be more, with you in the sense that we also think that training is very important, especially training data stewardship. So thank you for, exploring different categories of research infrastructure and also examples of successful data sharing. Are questions from the audience? Yes, please. Yes.
If I can take the microphone. Did you compare your findings with, in fact, the setup which is already for decades available in the astronomy and the observatories? Because there the model, I must admit that I am looking at that model as something as a holy grail in many aspects. So how it compares with your analysis, the way how they are able to actually work with the scientific data and make them available while still keeping the primary access for the PIs at the beginning?
Yes, so yes, we have a model, and we look towards them, and in fact, we work with them, and we work with international efforts such as the International Virtual Observatory to reconnect to these practices that they have developed over the years. But I have to say, even in astronomy, they still have some work to do. And for example, with CI Compass was engaged with the Arecibo Observatory and looking exactly at issues of PI data. And what they have is they have individual PIs that have made observations of using the Arecibo instruments. So all these files reside at Arecibo, but there is no way to easily discover it unless you want to look at the work of a particular PI or look at a particular day. So Arecibo is putting a lot of effort in harvesting that metadata from the FITS files that they have on record to build the capability to make it more available to the broad public, to the scientific community and the public. And so it actually is, even they don't have everything solved.
I would not say that. It's only that from my perspective, it is really kind of things where they were able very successfully to deal with many questions which you, in fact, presented in your presentation. But I don't want to take the time.
Yeah.
We can do that on the panel. Yeah. Thank you.
Thank you. Thank you. And now we will move in inviting the next speaker, who is Jianhui Li, who is computer network from the Computer Network Information Center of the Chinese Academy of Science. And Dr. Li will talk about digital research infrastructure to open science, the national practice in CSTCloud from China. Do we have the connection?
Yeah, thank you, Chair. Can you hear me?
Yes, indeed.
Okay, thank you. It's my great honor to join this event, even I can just join remotely. So I will share some practice in the digital research infrastructure for open science. I'm Jianhui Li from Computer Network Information Center, and also served as CoData, as a CoData Vice President. So I would like to say several words about our center. Our center is a special research institute of Chinese Academy of Sciences. So we are responsible for the design, development, and operation the digital infrastructure for our scientists in CAS. And as for the open research data policies, actually, as you may know, in 2018, the Chinese State Council launched scientific data management regulations. We think this is a basic policy for the research data management and open. It's intended to clarify the responsibility of officials and scientists who regulate and use of the information. And that regulation actually is to improve the management, security, accuracy, and openness of scientific data. So according to this regulation, the scientists, the PI, have to submit the data, research data, to the United National Scientific Data Center for archiving and for open services. So sorry, next. Oh, it's okay. Thank you. So China support to. Sorry. Oh my God. So, and the China government's Ministry of Science and Technology launched 20 national scientific data center in 1929. So each scientific data center is focused on one area. So the possibility for the National Scientific Data Center is to preserve the research data submitted by the scientists, and the integration of the different research data and the open and sharing scientific data. So this is actually a basic infrastructure for in national level to support the research data management and sharing. And as for in CAS, so actually in Chinese Academy of Sciences, there is more than 100 institutes across all around the country. So CAS, there are many major research infrastructure, and also we host 11 National Scientific Data Center. We also have many field stations and major international cooperation projects. So we produce big research data, and we also we will use the research data. So CAS actually have decade investment in cyber infrastructure development and e-science. And so actually our institute is the main institute to to design and development and the operation all these the digital infrastructures. It's including, we had a network we call the China Science and Technology Network. This is actually linked to the European with Qian and even the UK, the United States. And then we developed the Chinese national grid and the grid environment to support the computing. And we host 11 national data centers. And in maybe 5 years ago, we wish we can make an integrated distributed infrastructure for open science. It's just as UNESCO's recommendation, open science infrastructure should federated, accessible, internationally interconnected, and interoperable. So for us, we in order to make this infrastructure, we face a lot of challenges. For example, how to define an open architecture, and how to make a trust and a security infrastructure, and how to make interoperability and between the infrastructure and even the data and etc. etc. So we set up several principles. So we wish all the infrastructure should open and federation. We should follow this standardization and make it into operation. And we will find a sustainable mechanism to provide services. And all might be services for the users. The users should maybe unify and access all the services. So we started a project to build a national research digital infrastructure. We call it the China Science Technology Cloud. So it's actually it started in 2016, and CSC Cloud supports multidisciplinary open scientific research with integrated cloud services for discovery, usage, delivery, and also the data and the computing and even the software and so on. So we continue to get funding from CAS from 2020 to 2025. We support three users. One is the scientists, researchers. They will find their services. They will share data and use data. And we also support the service providers. So the software development, they share them software, the mechanism, any other services. And we provide service to the resource owners. So the computing facility, the cloud facility. So we wish we will make a federation infrastructure to integrate all together to provide service to the scientists. So this is we provide the infrastructure as services and some of the platform as service and many this software services. And so for data services, so we there are open data services. So we call the CAS Data Cloud. Actually, it integrates all the multidisciplinary data, and the users can access the data and even analyze data online. And here is now the data sets. There are more than 18,000. And so it's including different, the different areas for the earth science, the geoscience, space science, and so on. And this is the research data repository called the ScienceDB or Science Data Bank. So this is a public and non-profit infrastructure to support the researchers to load the data to this platform and to management and share. So there are more than many data sets can be accessed in this platform. And so this infrastructure also for many big science researchers. So for example, this is a big astronomy facilities, I mean the FAST and even the satellites, and this is the CAS Earth and some of the high physics and in the corporation, international corporations. So also this is the showcase for the SDG Sustainable Development Goals. So we support SDG big data platforms. So there are more than 10 petabyte data to provide to the users. The user can access data, analyze data, and even to do some data, produce data product, and even to do some decision makings. So this is a showcase. And we wish our CSC Cloud can, connect with the world, with other infrastructures. So so this is our goals to make it. So we started to cooperate with the EGI from the technical level, the infrastructure. So we set up a test bed, federate our cloud environment with the EGI the environment. So the users, the European users, can use the EGI's check-in system to access our resources. And The CSTCloud users can also use the CSTCloud AI system to check to access the EGI's resources. And this is an initiative actually needed by the CODATA. We call the Global Open Science Cloud Initiatives. Actually, the main goal is to build a robust network to bridge trusted research infrastructure among which different research resources are connected, and so to support the global open science environment. So by now there are 4 working groups established, and now is co-research now. And we select 5 case studies. It's including the SCAT radar data and biodiversity and the SDG, sustainable data in population health. And we launched our international program office hosted by CARES in IC. So to try to build a international network to make more people engage in these initiatives, and we hope more people can join us, and to make our platform, our infrastructures can be interoperability, can link together, and can to support the global cooperation research in the future. So thank you very much. That's all.
Thank you very much. Thank you very much for introducing we to the development of digital research infrastructure in China and in the China Science Technology Cloud. There are questions from the audience for Dr. Li? If not, I have a question for you. How do you involve people? How do you engage with the community?
You mean in CAS, okay, or even in international level?
At national level.
National level, actually, in CAS, we have a very big program we call research informatization programs. So our center actually has very strong link with all the the science community. So we provide the service to the science community. So actually we work together with the different institutes in CAS, because in CAS only our institutes to develop this infrastructure to provide the common resource to all the scientists. So we have a very strong link with them. So we make them involve us. It's not a very big problem now. Yeah.
Okay. So other question from the audience? If not, from Australia to California to China and now to Europe. I invite Suzanne Dumichel. Suzanne is a partnership coordinator of operas and member of the board of directors of the EOS Association, and she will talk about the role of the EOS Association. Thank you, Suzanne.
Thank you. Thank you, Marialuisa. So, yeah. Better like that, I guess? Yeah. Okay. Thank you for the organizer to invite me. I'm very glad to present the role of the EOS Association in the perspective of data sharing. So I will focus in this presentation on the one regional European initiative, which is the European Open Science Cloud, and especially through the focus on the association, the European Open Science Cloud Association, which is one of the main instruments to develop and to build this open science cloud in Europe. And I have to use these kind of things, yes. Okay. So the building of the EOS takes place in a general context, the web of fair data and services, and I won't develop too much because actually we already spoke a lot about it this morning. But just to give you the whole context, and we started with this idea of building this web of fair data and services, and now there are the different regional initiatives, and the EOS is one of them. And actually, I think this was Michael this morning, who highlighted the fact that the EOS is one part of the web of fair data and services. So let's focus now on the EOS Association, which is a specific instrument in the building of the EOS, because it's a key player, actually, to structure the EOS ecosystem and to engage and represent the scientific community in data sharing. So here you can see a picture of this community, the voice of the community. What is interesting and what you have to know here is that actually each of these persons represent a whole organization in itself. That means instead of hundreds of people here, you might imagine thousands of people that are part of the EOS Association. So what are the purposes of the EOS Association? There are three main purposes, and I will focus mainly on the last one, because I already mentioned the first one, actually. And the last one is to enable seamless access to data through interoperable services that address the entire research data life cycle. So you see that one of the main goals of the association is to deal with data sharing. So how we do that? By a specific governance that have been set up through a specific partnership, which is named the EOS Partnership. That means it's a tripartite collaboration between the EC on one side, so to represent Europe as a whole, the member state and the associated country on the other side that represent the national perspective regarding data sharing and open science cloud, and the EOS Association, which represent the community. So this is why the role of the association is quite an important one, because it is supposed to gather the needs coming from the community, which is both made by the researchers or the users, but also by the service providers. And all together, we are working through a specific partnership, the Memorandum of Understanding, where we engage the work that has to be done. So the association gathers, so it's a quite young organization, actually, established only 2 years ago, a bit more than 2 years, but with an efficient secretariat since 1 year. So that's why it's still a young organization, but with a strong member base, because we have already, as you can see, more than 200 members that are part of the EOS Association. And this organization is led by 8 directors plus 1 president. We are all elected by the members of the General Assembly amongst the delegates of the association. What is interesting here in the governance model we have is that we try to to highlight the diversity of our members by the diversity of the member of the board. That means diversity in terms of location, in terms of scientific domain, type of organization, type of stakeholder as well. So, and I think with this kind of picture, this is already the case. And how we gather all this community, actually, through a specific advisory group. So you have the title in bold, 5 advisory group, and 13 task force, which allow us to split the work and to be able to manage this community and the high duty we have in the EOS Association. So now I will present very quickly some of the task force that are related to data sharing. So I kept the title of the other task force, but I won't detail because we don't have time. So the first working group is, the first advisory group, sorry, is the implementation of EOS. And here you have a first task force, PID policy. I won't develop here, but of course working on PID is a way to reach data sharing. So that's the first thing. Second one, maybe the advisory group, with which has the most focus on metadata and data. This one, because the 2 task forces are dedicated to this topic. The fair metrics and data quality on one side, and semantic interoperability on the other side. And I would like to focus a bit more on the current work plans of these 2 task forces, especially by highlighting first that the result of this fair metrics and data quality will be presented at the EOS Symposium in Prague in a month, mid-November. That's the first thing. And for the semantic interoperability, we will provide, so this task force will provide in December a deliverable about crosswalk minimal metadata and set and interoperability indicators, which is built from the use case that have been studied within this task force. Let's move then to the third advisory group, research careers and curricula. Here, I would like, it's a bit out of the scope because it's data sharing, but I think we already mentioned that even this morning and even with the previous presentation. Training, of course, is also important in data sharing, and this is one of the scope of this data stewardship curricula and career paths. Then we move to the fourth advisory group, Sustaining EOSC, where you have one task force dedicated to the long-term data preservation with a detailed work plan also planned for this task force. Here also, when you speak about data sharing, there is this topic of immediate data, but also how to preserve them, but also how to make them available, even once they are archived in a specific repository. So this is the role of this task force to work on this issue. And the last advisory group, technical challenges on EOSC, with one task force, technical interoperability of data and services, which is currently working on the draft technical architecture that should be provided by December. So what is actually interesting here is that you can see, you might have seen that in each of the advisory group of the EOSC Association, the topic of data sharing is there and is addressed from different point of view. And I think this is, I noticed some similarity here with what you presented in the RDC building blocks, where you also have the training, the technical interoperability, and things like that. So that was interesting. Yeah, and so the global aim, actually, of this task force is to feed two very important documents for the EOSC Association, in which we are engaged, especially in the perspective, in the framework of the partnership. The 3A first, which is the Strategic Research and Innovation Agenda, which defines the general framework for future research, development, and innovation activities in relation with the EOSC. And the MAR, the multi-annual roadmap, which set the priority activities and outcome for 3 implementation levels, the national, the institutional, the national, and the European. So here you can see in the middle the 3 main objectives that have been highlighted in the actual version of the 3A and which are still available for us. These 3 objectives, you already know them because these are also the objectives of the open science at large. So they are the ones that drive us actually in what we want to do in the EOSC Association. And on the right, you can see that the MAR, the multi-annual roadmap, is built in 3 different phases. So this is why it's a multi-annual roadmap, in order to highlight the different priority. And we will move to a new priority from 2023, which is the expansion to production that generates added value. And I can maybe highlight that a bit more by highlighting the agreed priority for 2023 and 2024, and especially the fact that on the technical side, there is this interoperability and data search and the data quality. And in the involvement, you have especially the skills and recognition and rewards, which has to deal with data sharing as well. And now I would like to conclude actually with a specific statement, I would say, maybe not the one of the whole board, so I don't want to say I'm speaking on behalf of the whole board, but it was important for me to share that. When we say data sharing in the open science context, we also have not to forget, we shouldn't forget the fact that data sharing is also very concretely depending on the actuality and what is happening in the world. And we have noticed actually the need to collaborate more with the COVID, for instance, but we have also noticed some specific reaction coming from what happened in Ukraine and the relation with Russia. So this is something to be addressed also in data sharing, how we want to focus on how we want to address the open science and the data sharing perspective with this kind of political context. And this is why I would like to highlight this open letter. This is an initiative launched by the ZBW in Germany and made by a collective of researchers and individuals to say that actually we focus on two core theses in this letter. The first one is that the open science movement should address the question of whether and if so, under which framework condition closeness can be appropriate in global and political crises. And the second one, that openness mustn't be used to place sanctions in global political crises by closing open offers. So this is also something I think to be discussed, especially in the perspective of regional collaboration. And I think that's it, with maybe just a last word, saying that data sharing needs, we of course all know that data sharing needs technicality, legal interoperability, organizational interoperability. That's okay, and we are all involved in this kind of things to work on that. But what we also should do, maybe the kind of next step, would be not to forget that to succeed in that, we also have to continue building trust between us. Because you cannot share data if you don't have trust with another organization or trust with the people with whom you are working. So this is also something that can be on our own, on our different agenda. And when I say trust, it's mainly being enough confident to share things, documentation, strategy with others. So yeah, thank you very much.
Thank you, Suzanne. I guess that there will be comments for you, in fact. Can you please?
About your one but last slide on no sanctions and geopolitical mangling with open science, I think I agree with that, but what about reciprocity?
Yeah, it's completely true. Actually, we had a lot of very intense discussion in this group to build this letter. The question of reciprocity, we addressed it by making a difference between what has been decided on the side of the organization, the collaboration between organizations, and the collaboration between individuals. So if at some point we have to stop some collaboration because of political crisis, it has to be done on the side of the organization. But if you have strong relation with another individual in the country, for instance, this is how we try to answer to this question, you shouldn't stop the relation because of what is happening. So.
That's not what I meant. What I meant is we share all our data with, for example, Russia, and Russia doesn't share any data with us. Yeah, yeah. I think we have to give an example, actually. So if we start to say, you know, it's always risky to say, okay, if they don't want to share the data, then we shouldn't do as well. Maybe we can also, it's also a way to improve and to make some incentive in order to convince people. And we can establish, for instance, kind of ranking of how much we can share or how far we can develop the collaboration or not. But this is, I think, more case by case. I cannot give a complete answer to your question, actually. You're clearly younger than I am.
This was also my comment. But thank you, yeah. But thank you very much for opening this discussion. This is a big issue. But let's continue. And please, Tania Altamirano, please come to the podium. Tania is Academic Relation Manager at the Latin American Cooperation of Advanced network, Red Clara, and she will talk about Latin American research and education infrastructures, networks and alliances for data sharing. Tanya, please.
Thank you. Just let me set my time. And well, good afternoon. Thank you for the introduction, Marialuisa. And I want to say that it's really good to see some familiar faces and get the chance to get to know some new more. I'll use this time to present our experience in fostering networks and alliances for data sharing in Latin America and the Caribbean, within the region, and with other regions around the world. So we're gonna have these 3 main points where we're gonna move. Just to start, please let me give you just a quick overview of what's Red Clara, the Latin America Cooperation for Advanced Networks, an organization in this moment integrated by 8 national networks. We have been working over 20 years, almost 20 years now, developing infrastructure and technology services that are essential for research, education, and innovation. And usually when we mention the word connect, I know that what comes immediately to some of the mind is the fiber, and of course that's the core of what we do. But actually our actions and what we develop is more than that. And in that point, it reminds me and makes me think in the speech that Steve Jobs gave in Stanford when he has these 3 stories that changed his life and, well, actually, in some point, ours. Because at the beginning, he mentions that we got, you can, in some points, you have to put some points, and he talks about connecting dots. And that's what we are basically doing. We are in this moment putting some dots in specific actions. And at the beginning, when you are working, it is important to follow and to continue and trying to overcome to some of the challenges that you have in front of you. In this moment where our mission is dedicated to contribute to the development of education, technology, innovation, to foster articulation. And, well, of course, we have these all challenges in front of us to enable digital transformation process of education, science, technology, and the region in Latin America and the Caribbean. But, of course, we don't do it alone. We are connecting dots with others that are doing similar things than us and have the main objective around the world. And you might see here this big map that we are part of, where there are, as I mentioned, this big scenery that we are taking out part and that we are member of. Now, and just to give some key elements, we have institutions, we have universities from national networks. We reach over 2,000 students. We have developed more than 2,000 kilometers of fiber that hasn't changed the high capacity for data transmissions. But what do we do with that? Because we are talking about infrastructure. Well, we have actions at different levels, from the academic part that we foster from our working groups to enhance. And we are specifically on that because we coordinate these regional actions to overcome on priority areas like education, climate change, telemedicine, blockchain, cybersecurity, and specifically from the technical part, of course, we have this perspective and this work focus on services as EdROM, that some of you might know that this started in Europe, but we are really proud on saying that we have the country with more hotspots in the world, that is Brazil. And that's really good because this is one clear message on how we are really focusing on strengthening the relationships and what we have gone. But of course, to fulfill these needs and this infrastructure that we have, the process that we have need to grow and to be developed. And what happens? Well, we have projects like BELA that's absolutely dedicated to support the long-term connectivity from the European and the Latin American side to reach and to foster this education and academic activities. Basically, with this project, we have the construction of one powerful fiber cable that now units, and that's where we have two dots connected from Fortaleza in Portugal from Sines in Portugal to Fortaleza in Brazil. And now that it's a really high capacity available for the research and the academic community. This is really the start of a new era because with this project, and you can see here the topology, is a direct link that now can enhance the collaboration between the two regions. Now we don't have to go over it, we have it. And what is the next challenge is to see how to move forward with this. The BELA project has its first data transmission in September of the last year. We have been working during this time. We are finalizing on November in Uruguay. We're going to have this activity where we're going to have the official closing. And we immediately start thinking on what to do. And what's coming up? Well, there's coming the BELA 2 program that will be focused on strengthening what has been done with the BELA project. Why? Well, because it requires more dots. We need to have more connections and initiatives that accent the articulation of the communities. Because in this, for this part, we're going to have integrated Central America and the Caribbean. That is a challenge, but also the idea is from the regional and national networks to create public goods software, to have agreement, to have the strategic alignments on open science. This starts with dialogues. We're gonna start opening conversation for technical strategies because we have to come and overcome to this together. And what happens that, of course, open science is one of the key elements in all the scenario. Latin America has a long tradition in this area that can provide foundations to develop important leadership in the development and strengthening of this ecosystem. During the middle of this year, I mean around May, June, it was developed a white paper that incorporates different elements and that has it becomes to give a glance overview of how's the situation around the institutions and the requirements. It's a common effort that what aims is to put on a spot what is needs to be done. And if you see the requires, and I think that we have heard during the other days, some of the needs, and that we can even get to common points when we see computer resources, when you see and you open to trust and to really share the data, to have flexible collaboration tools, and to use sometimes not well approach the collaborative development environments. What happens? There are actors that are involved in this moment in the activity. You can see some also well-referred names in the other sessions, like La Referencia, Red Clara, that I'm presenting from High Computer Scalac, and some other experiences that come from the countries that are really focusing and involving from strategic spots for the continent to support the activities. But of course, the ecosystem is lacking on a regional effort of capabilities that have an integrated open data infrastructure that can be used to complete the tools required by researchers. So the main idea of having this and identifying the common activities and actions that has been developed is to have this reflection on how important it is to, for example, overcome the challenges that reduce the digital divide. How it is important, the cooperation with funded agencies in key institutions around the world. And of course, to have in mind that there is no regional infrastructure to store the scientific data. And as I mentioned, there are some really good activities that are becoming from countries, some institutions, but we need to link those spots and to have like a common activity integrated. What is the possible roadmap? And here I can relate that has been mentioned on the presentations before mine, because besides this really exactly to expand the connectivity, we have also to look the lessons learned from previous activities, from successful projects. We have to take advantages of what is already available on services developed, what is available maybe in other regions of the world or other institutions that you have now presented that can be open and integrated and safe and good provided services for the community. We need to look for those cases of success that can be taken an example for countries that may not have well-developed stages, because we deal in the region with differences of situation, strategies, government, interest, focusing. But these good examples can give you a starting point so they can know how to do it, how others that they can relate can approach this. And of course, we need to go on training and sharing experiences on this knowledge transference that is really important in this kind of scenarios. And there are, and I can now mention some initiatives that are also being taken that are linking to these efforts, like the Red Infra project. I know that they have had the meeting days before. They are also a project founded by the Horizon 2020, and it works for the construction of a regional map, collaboration between European Union and LAC countries, and that it's focused on infrastructure policies, that is putting on relevance what has been done, and other activities that we have had from Red Clara linked to our communities on specific topics, and that I think that we have to take good advantage of these collaborative projects to move forward together. And as I mentioned at the beginning, when you see these different actions, it might seem in this moment like distributed dots that are time to time together. But we have to move and walk trusting that with the decision and establishing, opening these doors for common actions to integrate efforts, starting even in basic levels, maybe in some years, as in the story of Steve Jobs, we can look back and say that we were ahead of having this common map. And of course, the main achievement is this bigger map for global collaboration. And I just wanted to finish remembering this African philosophy of the Ubuntu that says, of course, if you want to go fast, go alone. But if you want to go far, go together. Thank you.
Thank you, Tanya. Yes, we need to go together. I mean, open science, as we always say, is global. So if there are burning questions, I will take one. Yes, please. And then I will, in the meantime, also ask all the panelists to to come here. So please.
Thanks, Tanya, for the presentation. You've mentioned that there's no regional initiative in Latin America around data sharing, but there are country initiatives, like in Colombia, there's a Papyrus repository that some universities are adopting. In Brazil, EBICT is also working, building their national network of repositories. There are projects of
the CRIS Brazil.
Yes, and Peru.
Yes.
And you work very closely with
Yes.
LAVITRANO. So what are the obstacles for that regional approach to emerge? Is it budget, understanding of value, something else?
I think it will start for a political basis, I mean the dialogues. And that was what, at the first point, we are ahead in with the Bella 2 project. Why? Because it has to be a public policy. I mean, it has to come from how the countries work. It has to come from stakeholders, that they understand that it has to be an integrated vision. And I take your words of saying that there are initiatives in some countries that are really good, like in the CRIS in Brazil, the CRIS that they are working now in Peru, and they are already, for example, working closely with La Referencia. They are having this, but we don't have like regional strategy. We don't have a regional approach, and I think that it's lacking because, and I'm sorry to compare, but when you see the European Union, it seems like to be a block, but when you come to Latin America, are like these distributed dots that it seems that everybody's doing, but they own the same that the neighbor is developing. And the idea is to sit these actors, to see these stakeholders, and seeing that there are differences, of course, but there are common challenges that can be approached as the region.
So thank you very much. And this will take me to the first question. We do not have so much time because we are a little bit late. So how to share experience? Let's start with Suzanne.
How to share experience, okay.
And collaboration.
Yeah, sure. I mean, this is exactly what we are doing right now, actually, at least being aware of what is happening outside. That's the first point. And maybe, yeah, I can just highlight one thing. We can share experience also if we are able to share or at least to understand the value of the others. So maybe that could be a first. So it can be quite theoretical, not very concrete, but I think it's also part of the work we have to do. It's being able to understand what are the needs and what are the value and what are the specificity of the others.
Ewa?
Yeah, it's a good question. So I think, you know, I think I'm kind of pragmatic, and so I think to make progress, we have these challenges that we face, right? The climate and societal challenges globally. And so I think organizing around these challenges and bringing people together from this group and the scientists that work on the problems and starting to, work together on something concrete, I think would be good, so that you have continuity, between the ICRI meetings. And so I would suggest maybe something like that. And one issue I think that would be important and is important, I think, to the research infrastructures is the energy consumption that is so keeps growing, especially with all the digitalization and use of digital technologies. And I think this is something that all the RIs need to address.
Thank you very much. Please.
I think pragmatic is one of my favorite words. And I think we do have to really have a few identified issues to focus on. And we've started today, but I think actually sharing this is what we're trying to do next is going to allow us to spot those resonances between the different countries. And I will just mention one of the things that I think we all need to think about, and that's the very long-term retention of data assets, and I'm not hearing that that has been addressed anywhere. So it's thinking about what that solution could look like on a broader setting than a national response.
How to share? Well, I would agree that it's a good starting point, identifying common needs and common interest, but also in going to the practical and basic. It's good to be exposed to the different situations around the world, and I might think that it's good having this, having the information, having the integration, and having the exposure and the pilots. Maybe I'm thinking out loud on how to take that to different communities and different countries and expose them to different realities, and having like this open portfolio. And I'm sorry, the rough example, but on how it's being developed and how it's being undertaken around different situations.
So thank you very much. There are questions from the audience to the panelists? Comments? Yes, please. No.
Mark Leggett from Digital Research Alliance in Canada. I'm interested in Rosie's last point, and it highlights two deficiencies, I'll say, in the system, in the national context, which is the one I'm coming from. And I know in Canada, when you mention long-term preservation or archiving of data, our federal government just kind of goes, or the colleagues in the federal government that fund us kind of go la 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 la. They don't want, there's a real hesitancy to fund long-term infrastructure that stewards data. So one of the potential solutions is an international collaboration to do that long-term data stewardship, but then our funds need to be spent in a national context. So it becomes a self-defeating prophecy. There's a lack of will or ability to fund long-term data preservation, and an inability to allow national funds to escape the confines of the jurisdiction and participate internationally. Now I'm kind of speaking in generalities, and there are ways to overcome that, but I find, at least in the Canadian context, that's a challenge. So is that something that you see as well in your jurisdictions? Is it something that we could overcome in a larger global context?
I think there was and I might get this wrong, but something I heard earlier today was an Anti-Deficiency Act in the US, where you couldn't spend against money that you didn't have, and I'm getting some nods there. And I think from our funding agencies in Australia, the roadmap for investment in research infrastructure is shorter, and that's the barrier that we come up against. So at the moment, if I look to Europe and to CERN with Zenodo, I think the justification there is that there are 20 years worth of projects associated with this infrastructure, and it appears that 20 years counts as long term. You know, that's enough to give people the confidence and the trust to put their data there. So I'm now saying, in our context, okay, let's talk about 20 years rather than forever. I think the comment around not letting the money go offshore is something that we haven't even got that far, because we haven't got as far as saying we need a multi-decade solution, but I do think it's a shared problem.
Yeah, maybe. I think it's actually the collaboration already started. We have seen that in the different presentations, that we have already some connection with different parts of the world, and I think we don't start, it's not today the first start of something, actually. We have to remind that. So indeed, we have to put ourselves in a long-term perspective, and I think 20 years is quite fun, actually, to start thinking about it. But don't forget that we already started this kind of collaboration a couple of years ago, and we are just keep going on. And even the issue, we said that we have to identify the needs. I think we already know them, more or less, because actually we faced most of the things that I saw just right now are things that we already face quite the same. We focused on the training, the technical interoperability, the legal issue. So these are we already know the issue. Now we have to see how to address them collectively. Oh.
Yeah, I think we're almost out of time. But yes, I agree. In the US, it's also a complicated landscape. We have some of the issues like Canada has, especially if we're talking about NSF funding. If you're large facilities, then there's a commitment from NSF to fund the data preservation for 20 to 30 years. But a lot of projects have a very short term, 3 to 5 years, and then it's really on the PI to try to scrunch money to make sure that the data is still there. Or the website is alive. You cannot pay for a website after the project is done. It's true.
You want to, if you don't, you want to comment again, or? No. Okay, so oh, yes, let's give the last word to the president of the EOS Association, and then I will close the session.
Oh, well, I didn't want to have the last word necessarily, but I would like to add a comment to the last discussion. I think it should be more and more the responsibility of the organizations that take on projects and not of the PIs that take on projects. So if a PI signs, the organization is signing, and actually the organization should physically be signing and responsible for the data for a certain period of time after that. It cannot be the responsibility of the PI. So we should put much more pressure on our organizations.
Just one word.
Absolutely.
To mention within the discussion, I think it's also important to take into account a dimension that maybe it's not being discussed. It's a relative asymmetry that there is in the resources. Actually, we're struggling in that sense in Latin America in particular. No, in Tanya, we're making a great effort indeed, but so well. Just to take it into account, no, and it's being taken into account actually, thanks to the European Union in partly. And so we are. But the important thing is that the dialogue dimension, no, about with all the stakeholders, and that's what we intend to sponsor and to bring about. Thank you.
So. Thank you very much for this last comment. So dialogue, cooperation, willingness, and trust. So these are the key words that is a takeaway message for all of us. So thank you very much for your attention, and thank you to the panelists for contributing to this session.